The following is an interview I did with Ethan Weiner. If you weren't aware of his work, he's written literally hundreds of articles in magazines such as Sound on Sound and Tape-Op. He's been a professional audio engineer since the 1960s and he's been dispelling many of the myths prevalent in the audio industry for decades. He wrote the book The Audio Expert, which is used as a core textbook by various universities around the world, and he's also known as an acoustician and designer of electronic devices. Unfortunately, the internet connection wasn't that quick, so there's a huge latency of around 10-15 seconds, and so a quick back and forth exchange wasn't possible. So instead, I've had to edit it a bit to remove the pauses, but despite that, Ethan shares a wealth of information that he's gathered over the years and dispels a number of prevalent audio industry myths. So I'd like to welcome Ethan Weiner. How are you doing today?
I'm doing fine. Thanks for having me. And this will be fun. I love talking about this stuff. I love debunking myths and talking about all of it. Audio, music theory, electronics. It's all interrelated. It's all related together.
Your approach is definitely solidly evidence based, and you've been a strong critic of pseudoscientific information in the audio industry. And I've done a similar thing on my channel, but everything that I've been debunking on my channel recently, you probably already debunked 20 years ago. So a lot of the things that people were hearing on my channel for the first time, you've definitely covered this, and a lot of this is obviously in your book, but you've written extensively about this and made YouTube videos. So there's a lot of stuff which I think my audience is going to be very find very entertaining and interesting in terms of some of the more outrageous examples of pseudoscientific stuff which you've discovered over your career.
Well, there's a lot of nonsense out there, and it's not just audio. The supplements industry, selling vitamins and supplements is just full of nonsense. I mean, there's all kinds of products that don't do anything, they don't work, and they always offer you a money back guarantee. But how do you know if the vitamins are actually reducing your risk of cancer? And the worst ones of those, not to get too far off track, the worst ones that I hear are supplements for your pets, for your dog and your cat, because how is a dog going to tell you he feels better? And but anyways, yes, there's a lot, and yes, it's not only wires. The stupidest of the wire frauds, and these are frauds. The people who sell this stuff are either stupid idiots and they don't even know that what they're selling is nonsense, or they're intentionally deceiving people. They're criminals. I mean, they're actually lying. They know they're lying, and they do it anyway to make money. But the stupidest of the wire frauds are the power cables. You could see how, even if you don't know a lot of electronics, people have heard about capacitance, which rolls off high frequencies in a wire. The capacitance in the shielded wire between the center conductor and the outer shield is about 22 picofarads, per foot for normal wire. So if you have 50 feet of wire, and depending on the output impedance of the driving device, you could lose maybe a little at 20 kilohertz, 15 kilohertz, depends, uh, but but normally that's not a problem. And properly designed audio gear has a low output impedance and can drive, 20 feet, 50 feet, whatever it's meant to drive, whatever the specs say, it's depending on the application. But power wires, they just have to be heavy enough. A $2.50 wire from the hardware store, as long as it's 16 gauge, 14, whatever you need with a preamp or something, you don't need much. If it's a 300 watt per channel power amp, then okay, you need a heavier wire. But there's no audio doesn't go through that as long as the thing can provide the power. So these claims of increased transparency and width, I love that. The imaging and the width is better, and the sound staging improves, and the bass tightness improves, and that's complete nonsense. It's just a lie. The bass response varies all over a room. There's an article on my website, ethanweiner.com. I have two websites, realtraps.com for the acoustics business and ethanweiner.com for my articles and things that don't fit on Real Traps. There's an article on my personal website showing what I measured in a bedroom-sized space. I was actually measuring the effectiveness of bass traps. And I put a microphone at the listening position and then moved it over 4 inches and measured again. and the response was really, really different, even as low as, 20, 30, 40 hertz. There was a big difference. And you think, well, the wavelengths at, at 30 hertz or, 20 feet long or whatever, how could the response vary? It does, because there's so many competing reflections coming from all over the place, all over the room. So when people change their power cord or even their regular audio wires, and they sit down, now you're sitting over here, well, you're getting a completely different response. Now, it's true that your ears average out. What you hear in this ear is not the same as what you hear in this ear. So if you have a null in one side, maybe it'll be compensated in the other. But the response changes, and what you hear absolutely changes, and the imaging changes, especially if you don't have acoustic treatment, if you don't have absorbers at the sidewalls. So people think this, and I understand the stupid hi-fi magazines. I mean, these people are amateurs. They're really good at writing poetry, and but they don't really know anything about audio. But it bothers me when you see quotes from professional mixing and mastering engineers, recording engineers, live sound people that work for famous artists, and they're promoting power wires, and they're promoting other stupid stuff. Uh, that bothers me, because they have credibility, and people believe them. And so it makes it harder for me. I have to show graphs. I have to show proof that they're wrong. I have to show things like the response changing 4 inches apart in a room. This is why they believe this. Yeah, but it's a good cause, and I keep doing it, and I applaud you for doing it too.
Yeah, I've definitely encountered the same kind of sentiment where you'll show evidence of something and people will say, well, there just is a difference, but they measured the same. No, there is a difference because I can hear a difference. But then they decline to do an ABX test, or you can't get them to do. And there's all types of stuff like this going on, which is so prevalent in the industry. And you talked about the audio cables, the power cables. It's interesting because I actually bought fancy power cables, I don't know, about 10, 12 years ago or something. I remember I spent, I think, 1,400 euros, so maybe like $1,600 or something, on these fancy gold power cables for my mastering studio, because I got such glowing recommendations. And so I was quite skeptical, but I went for it because I thought, okay, well, if it's going to improve my sound that much, and I couldn't hear a difference. So I'd set up a microphone and decided just to record what was coming out my speakers with the fancy cable plugged in, with the fancy cable not plugged in. And the conclusion which I came to, with it was also power conditioning strip and stuff. It wasn't just the cables. It had some sort of supposed active electronics in there. But the conclusion I came to was that the differences in that there was a very, very slight difference in the recording, but it was repeatable, this slight delta, whether or not you've changed the audio cables. So it seemed to be just like the minute changes. Maybe I was walking around the room and the microphone moved 1 millimeter. Well, that was enough to produce more of a difference than the speaker, the power cables themselves actually produced. So I was fairly convinced after that it's a massive con.
Well, when people insist, and when they argue with me and say, "No, I can hear a difference. I know what you're saying, but I can hear a difference. There is a difference between this wire and that wire," and that's where the null test. Well, they say I can hear a difference, and then they say I can hear things that audio engineers don't know about. There are other parameters. It's not just frequency response and distortion, and and noise. There's other things that obviously audio engineers don't know about, because I can hear the difference. So that's why I explained to you about the acoustics and moving your head, and that's why I designed that null tester device, which is a YouTube video. And there's also an article about it that actually shows most of the schematic for how it works. I would have shown the whole thing. I don't have secrets on anything, but it just didn't all fit in the magazine. It was just the input section. But I show all the core stuff, and explain how it works. You take a signal and you send it equally through two wires, and then at the opposite end you flip the polarity of one wire and you mix them together. And if you have total silence, then that means the audio going through both wires is coming out at the other end exactly the same. So that was a really important thing, because it proves that there's no parameters or aspects of audio or properties that engineers don't know about. And nulling has been around since 1940s. Hewlett-Packard's first distortion analyzers worked that way. They would put a 1 kilohertz tone or whatever through an audio device and then notch it out at the output with cancellation. And whatever was left was distortion, noise, hiss, anything. And you could analyze the audibility of it. How loud is this distortion? Whether the makeup, how much third harmonic, how much second harmonic, whatever, how much IM distortion. They didn't have a lot of sophisticated analysis back then, but the concept of notching out the nulling out the 1 kilohertz test tone. This goes back, what's that, 80 years,
Exactly. The null test is pretty much the gold standard for dispelling this claim that there's some magical difference in the signal when you null it and it's not there. It's okay, it's scientifically not there.
Right, and ABX.
Yeah, ABX as well, yeah. I'm a big fan of doing ABX tests.
Yeah, or just plain old blind tests. I mean, it doesn't have to be an ABX device. I do blind tests with people here in my studio, and it doesn't have to be double blind. It's okay if I know what's what. I just don't hint as to what I'm doing. And, the people are sitting in a place where they can't see what I'm doing at my computer keyboard. Or if I do it in my home theater stereo listening room downstairs, which is a different room, they can't see what I'm doing. Or I'll tell them, close your eyes, or, whatever. And if they can't tell the difference, they can't tell the difference. And I've had people be very surprised that showed up thinking they were going to prove me wrong. And in the end, they go, wow, geez, I had no idea.
What would you say you would do in a situation where someone has, for example, magical stones in a jar? And I've seen you talk about this before, but they've got the magical stones in a jar and they say, well, you can't really record it and play it back because the magical stones work on a level which is more than just the vibrations, the pressure modulation in the air. It's actually the emotion is being relayed to my brain through the magic of the stones and stuff that gets into super esoteric and supernatural stuff. Have you encountered many people advocating for that kind of stuff? And what is your general response to that kind of stuff?
No, I haven't seen that much. People do talk about emotion and how that's a factor. My response would be, if you're so friggin' stupid that you believe that kind of nonsense, you're hopeless, and there's nothing I can say that's going to convince you that you're wrong. Take a night class in Science 101, and learn a little bit about the physical world. There is no such thing as magic. Yeah.
Talking of magic, though, I really feel that a lot of people think that there is some quality or character which almost seems like it's a magical description to do with analog hardware. There's a very sort of holy grail thing about having the original analog hardware. And if we get a plugin which replicates that, or we just say we have an EQ, which is a bell boost, and we perfectly match that bell boost with a digital EQ, and the parasitics aside, maybe there's some slight noise or some slight other things to the signal which are practically inaudible. The actual EQ that is being applied by the hardware, because it's analog hardware and it costs $6,000, there seems to be this real sense of that being the authentic sound. It sounds vintage. It sounds authentic. It sounds all of these things. What is your take on that? Do you think that there is some sort of truth to the original analog hardware versus the digital version?
Not really. Analog circuits obviously distort. So did digital circuits plugins, but anything that's done at 32 bits floating point, which is most stuff, the distortion of every operation, whether it's a single pole low pass filter, a volume increase or decrease, which is just adding and subtracting numbers, the distortion added is something like 0.00000, something percent. And I actually have also on my articles page on my personal website the results of tests where I took a pure sine wave. This was a while ago, so I hope I'm remembering it right, and ran it through a sonar project where I added 0.6 dB and subtracted 0.3 dB, and then added 0.9 dB and subtracted 7 dB, and did a whole bunch of stuff, 32 operations, and then looked at the distortion, how much was added from all of those math operations digitally. And it was really, really, really small. I mean, it was too small to hear. Anything more than 80 dB below the music or the sound or the test tone or whatever you're doing. Anything 80 dB or more down is really not going to be heard. Now, analog stuff does have distortion, and a lot of times the IM distortion is more noticeable than the harmonic distortion. A lot of people don't consider IM. They say, oh, well, tubes have even order harmonics distortion, and transistors and op amps have odd. Well, first of all, anytime you have odd, you probably also have even. And anytime you have either, you have IM distortion, and that is much more of a problem because that's not necessarily musical. Harmonic distortion adds overtones, harmonics, so they make a violin a little brighter, but it doesn't add dissonance. But if you have two notes like an A sharp, an A and a C sharp next to each other in a musical notes, you're going to get some indifference tones that aren't related to the key of the music. They're not even real music notes. And I have this is all in my articles, my book, my videos, my two AES workshop videos on YouTube. So distortion can be audible, but it doesn't have to be expensive. And I like distortion. I use overdrive plugins. I use for both obvious distortion, like to fuzz up a guitar that wasn't fuzzy enough when I recorded the lead through an amp, or just add a little bit of grit, a little bit of, they call it glue, to a final mix. I like that. I believe in that. I've done that. My first experience, going back 20, 30, 40 years, well, 90s, maybe, early digital recording. I'd recorded something digitally, and this was before we had CD burners. So I made a cassette to mail to a friend. And when I played the cassette, it sounded better. It had the hiss, but it sounded better. It sounded more like a record because of that slight distortion. So I was a believer. This was like 30 years ago, something like that. So I'm not opposed to that. But distortion doesn't have to be expensive. One of the articles I wrote for Audio Express magazine, and these are all linked on my articles page. Either the articles live on my website, or sometimes they link to, a magazine's website. Is a little device I made. It's just passive device with 2 diodes and 5 resistors and a capacitor called the Mojo Maestro, and it would add subtle or severe distortion with a knob. You turn the knob, and you can get different amounts of distortion. And there's example files you can download that go with the article when you download look at the schematic and read about how it works. So, to spend $7,000 on some, massive passive, summing mixer or something just because it has tubes and transformers, is just a waste of money. You don't need that. Now, I'm not opposed to people spending money if you have it. There are people, rich kids, whose daddies, millionaires. I don't mind that people spend money, and I like nicely made stuff. Things that are expensive a lot of times are really well made. Made like a battleship. They're not going to break down in the middle of a session if you're, Capitol Records or some big A&R recording, whatever. And you're recording a movie soundtrack. You have 100 players all making, $250 an hour, plus the conductor, plus the studio. You don't want your direct box to fail in the middle, or your preamps or whatever to break down. So I like well-made stuff. What bothers me is when you have these amateurs, they're kids, they're school kids, they're 20s, somethings, whatever, and they don't have a lot of money. They can't, you could buy 6 Audio Technica 2020 microphones. To me, an Audio Technica 2020, what, $100, is basically a U47, except it doesn't have the Omni option for a pickup pattern. But it's basically a transformerless U47. It sounds great. It's a big, large diaphragm condenser mic. So you could buy 6 of those, or you could buy one, expensive mic. If you're a kid and you don't have an unlimited budget, and I'm not saying buy 6 of the same mic. Different mics sound different. Though mostly, really, it's just EQ and pickup patterns. But you should have small diaphragm microphones. They are very different than large diaphragm microphones. But my point is, you don't have to spend a lot of money unless you have it. If you have it and you like nice stuff and you want a lot of jewelry, that's what they call it in the hi-fi circles, is the fancy cables, and they come in, really fancy boxes. It's not just a wire in a plastic bag like you get from Amazon. They come in teak wood boxes with felt lining, for $1,200 for a meter, wire. And so they call that audio jewelry. And
I actually couldn't agree more. Yeah, especially your point about intermodulation distortion is interesting because, as you say, a lot of people overlook that or don't even know about that. And one of the things that I find the most important element in when I try and make like freak beat style tracks or like psychedelic rock, like garage rock style stuff, one of the secret ingredients that I've found to really making that sound the way that it sounded back then is intermodulation distortion with especially low frequency stuff like all it's getting into almost like amplitude modulation at that point that you can use really low bass sort of modeled parasitics of like a bass hum or something and feed that as a pre-emphasis like sort of in with the signal into the distortion unit, and it will distort it in a much more non-linear way than without that low frequency tone. And you can or just like boost the low frequencies a whole bunch into the distortion and then take that out after, so like a pre and post emphasis. And that stuff like really gives a tone way more complex and related to what I'm hearing in mid 60s recordings than just your standard overdrive or whatever alone. And and the point about the fancy the hardware stuff, like I'm a real enthusiast of Eurorack modules, so I know that I can get the same kind of stuff in the digital emulations, and it probably will sound the same. I might not even be able to tell the difference, but I just like having the hardware to play with and turn the knobs, and I just like it visually and in terms of me just having fun sitting there turning knobs with physical equipment. I really like Eurorack stuff and some other studio gigs. Just working in the studio, sitting behind a Neve console it's just a fun thing. It just makes me happy. But in terms of the actual audio quality itself, as you say, there's a lot to talk about in terms of distortion and the different types of distortion. But and that's a very important point. But I guess this could segue into your opinion on mic pre's, because there's a lot of voodoo and stuff about mic pre's. And of course, different mic pre's might distort slightly differently. Let's say you've got a really cheap one, it might do some crackly, horrible distortion when it overloads, versus some Neve console, which does really nice kind of overdrive when it distorts. But apart from that, the clean gain at least. What are your opinions on the differences between different preamps?
Okay, well, before we get to that, let me just go back to what you were saying before. I understand that people like hardware. To be able to touch things. I'm not a fan of that. I'm 75 years old. I've been doing this since the 1960s. I've had 3 recording studios in the late 1970s. I built what was the largest recording studio in the state of Connecticut here in the U.S. And we did all kinds of stuff, a lot of jingles and a lot of corporate stuff, a lot of rock bands. I mean, we did a lot of stuff. So I've been doing this forever, and I really like doing things in software. But I agree that the problem with software is you can only do one thing at a time. When you have a console and you have a bunch of faders, you can work a couple of faders at once. Uh, but there are so many advantages to software, like perfect recall, as opposed to trying to set all your outboard gear knobs exactly the same as they were if you want to bring up a mix 2 weeks later. But I understand that, and I'm not opposed to that, and I don't tell people they're wrong for liking hardware. The other thing you mentioned before we get to my preamps is, the 1960s, sounding like the 60s. Back then, obviously, analog tape was the big deal, and they had 1-inch and 2-inch tape. I think they had 2-inch tape back in the 60s, certainly 1-inch tape on 8 tracks. And back then, the engineers and the chemists at Ampex and 3M and BASF, the tape manufacturers, and the engineers at Ampex and Scully that were making the recorders, they weren't looking for a tape sound or a tube sound. They were looking for the cleanest sound they could get with the least amount of distortion and the least amount of noise. And the tape formulations, that's what they aimed for. But noise and distortion were inevitable. And with analog tape, they boost the treble automatically. It's behind the scenes, but they boost the treble when recording, and then cut it back when playback just to get rid of the hiss. And the same thing with records. The RIAA EQ curve boosts the treble and cuts the bass when pressing a record, and then every phono preamp that you have in your hi-fi setup reverses that to get it back to flat. But the distortion, you got your master tape, then you do a mix down to the two-track stereo, so that adds a little more distortion. And well, you don't send that to the record pressing plant. You make a copy, or maybe you send the original, but you make a safety copy. So there's more distortion, and then they cut the record, So you end up with a lot of generations with distortion. But as I was saying before, distortion doesn't have to be expensive. You can do it with a couple of diodes. Transformers do distort differently. You can buy a $6 transformer. That's one of the things I show in that Mojo Maestro article they mentioned, where it's just a couple of resistors and some diodes. And you can buy a cheap transformer. If you want transformer sound, don't buy a $120 transformer from Jensen. Those are really high quality. They don't have the transformer sound. They are clean. So if you want a transformer sound, do a little experimenting. And this is why I encourage people to learn a little electronics. And again, before we get to the mic preamps, because I have certainly something to say about that, my audio expert book has been out for about 10 years, and now in the second edition. And it explains how audio works and explains all this stuff. There are so many books that tell you, here's how you work a compressor, here's what the knobs on an EQ do. But I have all that, and I think it's explained very clearly and completely. But it also explains how the circuits work. There's a whole chapter on basic electronics. It's not physics level stuff, minimal math, but it explains how what transistors do, how transformers work, and resistors and capacitors and filters and stuff. The book I'm working on now is different. It's called the Audio Circuits Cookbook, and it's a collection of many, many, many audio circuits that hobbyists and professional engineers too can use. And one of the circuits is a professional level microphone preamp with phantom power. There's two different types of compressors, plus a third compressor that goes into a stop box for use with guitar effects. There's a whole section on pedal effects, and a lot of little pieces of circuits that you can put together to make a complete device. If you're making a compressor or a noise gate, you need to know how loud is the audio coming in. On a gate, do I turn it off because it's too soft, or on a compressor, do I turn it up because it's too soft, or turn it down because it's too loud? So you need what's called a full wave rectifier that looks at the positive peaks and the negative peaks. We've all seen audio waveforms in our DAW, and some of the peaks go up, some go down, and sometimes the positive is more. So you need a full wave rectifier. It's something done with 2 op amps and 6 resistors, and it's not complicated. But you need to know how to do it. There's peak followers if you're making an envelope follower, an automatic wah-wah that follows, the guitar player. You go, you pick, and you go wah every time you pick the note. You need what's called an envelope follower, and that's also, an op amp or two, and a capacitor and resistor and a diode and stuff. So there's more. I have more than 80 circuits so far, and it might be closer to 100 when I'm done. So I just wanted to get a plug in for my 2 books. And I can tell you about preamps.
I'll buy the electronics one when it comes out, definitely.
It's really great because it's not just a bunch of circuits. And I didn't invent the concept. Back in the 1970s, National Semiconductor, who was now owned by Texas Instruments, but they were a huge semiconductor manufacturer. ICs, digital ICs, analog op amps, transistors, diodes, a huge company. They put out these books that they gave away for free to audio engineers or the electronic engineers. It wasn't just audio. In fact, it was a lot of radio stuff and general electronics, high voltage things. And they were really good books. I'm talking, real books, like that you would pay $25 for or $40 for today in a bookstore, that had tons of circuits, little pieces of circuits, including complete things. There's a complete 10-band graphic equalizer. And it used simulated inductors, which is an op amp circuit, a little thing with 1 op amp, 2 resistors, and a capacitor, rather than real inductors, because real inductors distort at high levels. They pick up hum from nearby guitar amp transformers, and they have and they're expensive and they're heavy. So they use simulated inductors in this. So there's a whole pile of circuits. So that's where the idea came from. And there are other people who have done books like this. But this isn't just a collection of circuits. It's a lot of really in-depth explanations. No math or minimal math, really just clear, plain English how the stuff works. But when you were talking about cheap preamps, fuzzing out and crackling, no, they don't. The cheapest preamps are made with an IC called an NE5534. Or 5532. They have either 1, 2, or 4 op amps in a single chip, and they're like 60 cents. for a quad, or 80 cents, something like that, for four really high quality, low noise, low distortion op amps. Now, these are old. These are 20 years old or so. There are newer ones today. There's one called the OPA 1611, I think, or 1612. It's in my null tester article, that has 0.00000 something 1% distortion. Under special circumstances, you're not always going to get that. But, so the state of the art is really good. But again, anything, if you get the distortion under 0.01 or 0.001, 80 dB, 100 dB down, nobody's going to hear it. So cheap preamps are made with that. I recently bought a Tascam 8-channel interface so that I could do surround mixing in my living room home theater. And it has preamps, and they make a big point. It says, we're proud to say we use any 5534 op amps for our preamps. Well, good. There's another book out called Small Signal Audio Design by an audio expert, Douglas Self.
Yeah, I've read that one. Yeah.
Yeah, and he talks about how to get the lowest noise out of all these things, and he recommends them for it, all but the most critical stuff. So cheap preamps don't have to sound bad. They don't have to have a lot of noise, and they don't have to crackle. Crackling comes from bad connectors and bad switches and bad potentiometers, or they're old, and if you have something that never, turn the knobs every once in a while to, to avoid that in the future.
You think with clean gain, you can't really hear that much difference, because obviously you can go and buy a preamp which is 2, 3, 4,000 euros in a fancy rack with maybe two inputs, XLR inputs, and it's thousands of euros or dollars. And people want to think, or they routinely do think, that there's a huge difference between that kind of expensive equipment and some more low cost interface like a Tascam or Focusrite low cost interface. So, in your experience and maybe what you've measured, you think that there's not really any huge audible difference between both expensive and cheap.
No, there isn't. There's no audible difference, and there's no measurable difference. One of the articles on the Audio Express website, but linked from my articles page, is called "Stop Worrying About Coupling Capacitors," because people worry about that. I see that in the hi-fi circles, because inside electronic devices there's capacitors, and capacitors can add distortion in certain situations. So I measured a whole bunch of different kinds of caps: mylar caps, electrolytic caps, tantalum electrolytic, ceramic capacitors, and showed the results. And I did it using my Focusrite Scarlett interface, which has very, very low distortion. And you can see the inherent distortion of the interface. And that's way, way, way down there, 80, 100 dB down below the music. Depending on the frequency, it rises a little bit above a couple of kilohertz. But it still, rises up to 0.01% from 0.001, whatever. And so some of these caps are so good that they didn't increase the distortion of the sound card, and the ceramic caps were awful, depending on how they're used and how much voltage is applied across them. And
I guess it's the same thing with carbon film resistors.
right, well, yeah, they're better than the older carbon composition, and now they have metal film. Everything these days, or most things these days, are made with surface mount parts, and they're all metal film, either thick film or thin film. And they're all at least 1% and 0.1% resistors. My friend, the genius engineer who guides me on all this stuff, I don't have an engineering degree. I've learned a lot over the years. But this fellow, Bill Epler, he says resistors are free. And they are. I mean, even if you're just buying, 10 at a time, they're like, 6 cents, 10 cents, whatever. And if you buy 1,000 to manufacture something, they're like a penny. They're free. Good capacitors can cost a little more.
Yeah, it's interesting to get that take, because I think a lot of people just see, well, this was built with, it's got really high price tag, it was built with accurate components, and it's got all of these expensive parts in it. What are the categories? You've got distortion, you've got frequency response, you've got noise floor. You can inquire about certain things, and if it tests the same, then yeah, it might be really well built, like you said earlier, with the you're recording at this fancy studio, and you've got a whole orchestra in there, and you don't want to buy the cheapest thing in the store, because you want it to be really reliable and stuff. But especially, as you say, for aspiring audio engineers, who don't have that much money, they think they're really missing out sometimes on if they could just access the Neve sound or the SSL sound or the API sound, but they can't afford it, and so they think that they really don't have the tools to get professional sounding mixes or recordings because, well, obviously you're going to need a Neumann microphone and API console and all this stuff to get a professional sound, or you're going to sound amateur, right? Because you can't just use modern low cost audio gear and get a good sound, even if it measures the same.
But people they don't know how to compare properly. Somebody will say, "Oh, I recorded this rock band and I used this, and I got a new microphone, and the next day I recorded a different rock band. Wow, this microphone is so much better." Well, that's not a comparison. You had a different singer; it was a different distance from the microphone, from the mouth, in a different part of the room, or there was a different guitar and a different guitar amp and a different player. That's just ridiculous. You can't do that. And another myth that's really worth busting is that, well, with the high quality gear, it's easier and faster to get the results you want, and that's just not true. I mean, it's just doesn't make a lot of sense logically. And not all plugins are the same, and not all. Well, most EQs are the same. There's a famous article where this guy got something like 20 different plug-in EQs, and he got them all to null almost completely, or very close to completely. Uh, Proving that they all, if you go to school to learn DSP and you take a DSP college course, which is really heavy in the math, and they show you these algorithms. These are in college textbooks, which are expensive. Okay, so you buy a $90 book and it has all the algorithms, and it shows you, well, everybody uses the same EQ circuit. Well, it's not a circuit, it's the code, because this is the most efficient. It uses the least number of CPU cycles, it adds the least amount of distortion, it runs the fastest, and so all the EQs pretty much are the same. I have some really old stuff from Sonic Foundry, SoundForge, and the original Vegas video, and this is going back, I think, probably 30 years also. And their plugins were not like that. Their EQs were a little weird. They had a quality slider, from 1, 2, 3, or 4. How much quality do you want? Because the computers were slow and they didn't have a lot of memory. So if you wanted just to hear something quickly, you go for low quality and know that it'll be a little better when you do your final render. So those were not the same EQ algorithms that everybody uses today. But really, the differences between these things, these plugins, is analog grit that they add, and hopefully you can turn it off. And with the Neve consoles, if you overdrive them, and it's true, overdriving one preamp can sound different than another. I don't think it has anything to do with how much the preamp costs, that the more expensive ones sound better when overdriven. Personally, I don't do that when recording. I want to record as clean as possible, and I'll add my dirt and grit and glue later when I can hear everything in context, when I can hear the bass and the Rhodes piano and the lead guitar and rhythm guitar and drums. I want to hear it all together, and then I can mess around with dirtying things up. And, oh, that's too much. No, that's not good. The next day I'll change my mind. But all this stuff was recorded and captured absolutely as clean as possible. So that's what I do. And I know people say, no, you got to commit early. Okay, if you want to do that, fine. And you can still commit. You can record clean, but put your effects in the playback chain. So, and you're monitoring in real time, or, 4 milliseconds later. So you can actually hear what you're doing, but it still is getting captured perfectly clean. So that's would be my answer to that. To people say you should commit, but I don't see an advantage to committing. I honestly don't. All that does is takes away the option to change something later. You can change EQ if you remembered what you did. You can undo it completely, and that's one of the things in my Audio Myths, AES Audio Myths, a demo video actually show applying EQ and then undoing it completely, and then nulling the result, showing that it undid it completely. But you can't undo compression and limiting, and you can't undo intentional distortion. You just can't undo it. So I don't see an advantage to doing recording that way.
Yeah, I totally agree with that, and that's my approach as well, to record clean and then do the distortion stuff after. And as you say, distortion doesn't have to be expensive. The saturation sound, well, you can get a guitar amp and stuff, put stuff through the guitar amp, and then record it with a microphone for a cool effect if you've got a guitar amp hanging around. Or you can, build your own circuit, like you've written about, using transformers or or yeah, diode clipping, and all of the great stuff that you've already mentioned. It doesn't have to be expensive, and of course you can just use plugins. But I really agree that distortion and destructive type processing, such as saturation, limiting, compression, it should really be done later in the process. I'm not a fan of keeping an infinite backup of every stage of
Right.
everything. At some point, you've got to commit. But I mean, yeah, some really good points there. I think. Would you be up for doing a bit of a quick fire? And because we're coming up to now, we've already been talking for about 45 minutes. So that's a really nice length already. I think maybe we can do a bit of a quick fire and then call it a day.
Okay, sure.
So, first quick fire question. But I can hear the phase. What would you say to someone who says they can hear the phase?
No, you cannot hear phase unless it's like huge amounts. You can hear phase cancellation when a source and a phase shifted thing are combined. That's how you make flangers and phase shifter effects. But phase shift itself is inaudible, and that's also proven in the AES Audio Myths video on my YouTube channel.
Nice. And what would you say to someone who says, okay, well, one instance of this plugin or one of these processors might not give you the sound, but when you combine it on every channel, even if you're just if it's like the end result is the same processing, but you're combining it on every channel, let's say like an EQ, just EQing it a bit on every channel versus just doing it on the master bus, the stacking gives a more somehow better sound. What would you say in that circumstance?
Yeah, that's also wrong. It's just wrong, and that's another myth that's busted with proof, with hard proof, and examples and showing how it works on my in the AES Audio Myths video. Stacking is it's just a myth, and it doesn't make sense logically, and it's easy to disprove with proper testing.
I've seen €700 USB cables, and obviously, if it's €700, it's going to reduce the jitter and make the audio quality from my USB interface to my computer just way more pristine, right?
Yeah, well, jitter also is a non-issue, and that was one of the most important articles I did not that long ago, within the last year, linked on my website at the Audio Express magazine's website with a demo video that you can view, and I let you hear jitter from really small amounts, what is actually typical, nanoseconds, up to very obvious amounts. And until you get jitter that's literally 40,000 times more than what you'd get from even really crappy wires and crappy gear, it's absolutely inaudible. And these examples absolutely prove it, again, with detailed explanations in the article and the video. And I have a bunch of different kinds of music. I think there were 4 different musical selections. And the whole video is only like 4 or 5 minutes long. I don't make you listen to a whole song, but it's 20 seconds of this, and with no jitter, and with actually I increase the jitter this much and add more, then add more, and then add more. A jitter is just a non-issue, and there's nothing you can put in a wire. It depends on some USB wires have error correction, some don't. Streaming audio does not have error correction, but when digital audio fails over a wire, it's obvious. When you were talking before about crackling and spitty sounds, that's what you get. You don't get a subtle degradation where, the imaging, the width is not quite as wide. That's not what happens with bad connections or inferior wires.
DSD obviously sounds way more analog, pure, and pristine than 24-bit 96K digital audio because the PCM is stepped. There's these little steps, and you can hear the little steps. But DSD, you can't hear that because it's way more analog sounding.
Yeah, well, that's also, of course, wrong. If PCM audio really had steps, then that would manifest as distortion, and you would see it as distortion. A good sound card, even at 16 bits, forget the 24 bits, and that's the main advantage of more bits is less distortion, not so much less noise, though that too. But if that were true, you wouldn't be able to get 0.0001% distortion of the 16 bits. So those steps they're not even really present. There's a fabulous video by Monty Montgomery where he explains digital audio. It's about 22 minutes long, and it's linked somewhere on my website, but just search Google for Monty Montgomery. I mean, YouTube. Search YouTube for Monty Montgomery digital audio, and it's brilliant. It's a brilliant video. It's one of the best videos I've ever seen. And it just shows that there are no steps, and it explains why. There's a unit, a circuit in every digital analog converter called a reconstruction filter. And that fills in the steps and turns it into smoothness between the steps that were sort of there. So yeah, so again, nonsense. And DSD, I'll mention, DSD has its own problems. With a lot of ultrasonic noise, really high level ultrasonic noise that has to be filtered out severely. And if it's not, you blow up your tweeters, or you blow up your amplifier. I'm not a fan of DSD. It solves a problem that never existed.
So I don't need any acoustic treatment at all in my studio because I can just get room EQ. Room EQ does an amazing job at smoothing out the peaks and troughs in the frequency response. And before I put the room EQ on and after I put the room EQ on, there's like a huge difference. Before it's like the big peaks and troughs, and with the EQ, it really smooths out the frequency response. What would you say to someone who thinks that?
Well, room EQ can be useful. It absolutely does not replace bass traps and other acoustic treatment. It can't do what diffusers do, and it cannot stop early reflections from the sidewalls and from the ceiling, where you would have a cloud and you would have sidewall absorbers, because those create comb filtering, which is a whole bunch of peaks and nulls. And you just move your head a little bit, and all those peak and null frequencies shift. So there's no way that a single EQ curve can fix any of that. What it can do is it can reduce modal peaks. And by modal, I mean things that are related to the room dimensions. But it can't change things that are positional, because every time you move your head, you have a peak at 100 hertz here, so you drop it down. But over here, you have a null, and now you have even less than what you had, so now it's even worse. Overall, it can help as icing on the cake, but it absolutely does not replace treatment. And just, it can reduce modal peaks. It cannot improve nulls very much, and it cannot do anything for comb filtering and reflections or reverb or excess ambience. And it can't do any of those things. And again, there's an article on my personal site called "The Final Dirac Report," where I mentioned the Dirac system, but I also have links to other earlier articles I've done with all the proof of all this. And with the Dirac, when it tries to raise nulls, it adds ringing. It adds, sustaining, to your bass notes. It actually makes the things worse. So yeah, it sounds a little fuller at that null frequency, but now it has an extra time delay time component you didn't want. So yes, it's useful, but it's not a cure-all for sure.
Yeah, definitely not a panacea.
Multiple subwoofers is a better solution.
Was that multiple subwoofers? Yeah, I normally work with stereo subwoofers, and I've done so for years. I think it's quite an improvement over one subwoofer, but I would say that it's quite room dependent as well. If you don't have the acoustic treatment on point, then yeah, if you've got a really poorly treated room, you really need to reduce the reflections in the room and get the RT60 times down, and even up some of those the modal frequencies a bit before you start worrying about speaker placement too critically, in my opinion. The chain of events that someone should do if they want to have a good sounding room would be, number one, probably get some bass traps. How would that order look for you?
Well, the first thing to do is find the best place for your speakers. And the popular program Room EQ Wizard, REW, is free. They have versions for Mac and for PC and even for Linux. And it comes with a program, an app, a component called the Room Simulator. And if you have a rectangular room, if you have an odd room, then it's not going to work quite right. But if you have a plain rectangle room, you can actually experiment with where the speakers go left and right, up and down, forward and back. And it handles, I think, up to 4 subwoofers. And you can see the response at the listening position, which you can also move left, right, forward, back, up, and down. And, in half an hour, you can find the best starting point for your speakers and for your head. There's an article on the Real Traps site called How to Set Up a Room. And it shows that where the best place to put your head is. And then and also shows you how to experiment with these things. So that's the first thing, and then bass traps and other acoustic treatment, and then the last thing would be EQ. And if you have enough bass traps, you don't need EQ. I have a fabulous home theater living room set up. And it's a big room. It's 25 feet front to back, 16 feet wide, and has a peak in the middle, 11 feet high and halfway back. And I have a lot of treatment in there, but there was still a little bit of a boost at 44 hertz, which is the second length mode, front to back. So I have a one band cut only parametric equalizer just to reduce that frequency by about 3 dB. And that was needed. I mean, that really helped, even with a lot of bass traps, but that's like would be the most you need. But the deal with multiple subwoofers is that will flatten the response and make it even more even around the room. So that when I was talking about here, you get one thing and 4 inches away, it's totally different. That helps that, but it won't reduce the ringing in the room, the time component, where certain bass notes, the bass player goes bup 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 bup, and in the room it's buh 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 because that note sustains. So and multiple subwoofers won't fix that. Only bass traps can absorb that energy. But multiple subs are absolutely useful. I don't have that. I just have a lot of bass traps and one killer subwoofer in my home theater and no subwoofer here in my studio. You can't see it here, but I have a pair of old school, really big JBL 4430 speakers with a 15-inch woofer and a big biradial horn. And so they go really low and really loud. I can have live jams here, play drum loops through that and have friends over to play keyboards and guitars and bass and stuff. So I have these big speakers, and I don't have a sub. They don't need a sub. They get on a 34 hertz, I think, 3 dB down, which is low enough for what I do.
That's a good response. Yeah. Well, Ethan, it's been a pleasure. Really nice having you as a guest. And apart from buying your book, The Audio Expert, where can people find out more about your work?
Well, everything is on my website. There's an audio bio page. It has, it's not a whole lot to read. A couple of screenfuls of, how I started and stuff I've done over the years. We were talking about fuzz tones before. I actually show a fuzz tone I designed in the 1960s that was really popular. I used to build it onto a tiny, tiny little circuit board and put them inside people's guitars. I think I charged $25 or something. And the circuit for that is there, and it still works. I made one recently, and it still sounds really good. So there's all that stuff. There's a lot of articles that turned into my book, and my YouTube channel also has a lot of information. I can email you some things that you can put on this video's description if you want, with links to stuff that people will find useful.
Thanks so much. And I hope my viewers can go and check out some of your work because it is extremely good quality and you're debunking all of the pseudo-scientific myths that are floating around in the audio industry. But not just that, you're really educating on a great level how to be an accomplished audio engineer. So thanks for coming on.
Okay, thanks for having me. This was a lot of fun. I liked it.